Thanks. It's good to be here. I flew in at 2 in the morning. So I'm here to talk about something I did 20 years ago. How many of you did something 20 years ago that is used all over the world by billions of people? It's not a good feeling. But it was necessary to persevere to make it better. Things that are impossible just take longer. I'm going to talk about the past and the future today, and I hope not to get stuck in the past because the future is brighter. When I was lured to Netscape in 1995, it was with the lie that I would come and put Scheme in the browser. And that didn't happen for reasons. Anyway, but there's an irony here because some of you have been following John Carmack of Oculus, Facebook, formerly of id Games' work on VR. He's using Racket in his version of the metaverse. He's got a little Racket server for his VR world that he's building. This led to this Twitter exchange where I said that I did something once in 10 days in response to Tony Parisi, who said, hey, come on, John, just spend 10 days and get JavaScript in there too, along with Racket, or instead of Racket. And I said this would be sweet revenge if we actually had Racket, PLT Scheme, in the future of the internet, if it's really the VR world, if it's the Matrix. And then Mark Andreessen trolled me like he always does, because he was my co-conspirator in JavaScript. And he always has to rationalize his past misconduct. And the only way that JavaScript could have succeeded was if it had to look like Java, because otherwise no one would have used Scheme. This is questionable. But there was a change when I got to Netscape. I was recruited saying, come do Scheme. When I got there, it was do Java or maybe a second Java-like language, because they were doing a deal with Sun, and Java was going to be the biggest thing ever, and it was going to kill Windows. It didn't happen. It was very hard to justify doing the second language in addition to Java. If you have Java, you've got one problem. Why do you need two problems? But Andreessen and I and others, Bill Joy at Sun notably, saw that Java was not accessible to the average web designer, programmer, amateur, and we needed a little brother language. And so when I did that, I took some damage. In 10 days, I created a demo which then shipped, and that led to a lot of the craziness in JavaScript. Some of it was just me compromising with people who wanted dynamic language follies. Here's Gary Bernhardt on JavaScript.
Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object.
It's a string.
Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object.
No, it's a string.
If you do object plus array, you get exactly the same thing, which, as you can see, you do.
Of course, because it's a C-like language, because it has to look like Java, the line starting with a left curly brace is a block, not an object literal.
And finally, the only one of these that's actually true is, because you add arrays, you get empty string, that doesn't make sense. But an object plus an object is actually not a number. This one's actually right. And, exactly, right? Like, what is even going on? I don't even understand.
I think he's using a Brita. He's a Rubyist.
I get array 16 things, which it represents as 16 commas, which is obvious.
15 commas.
And, string, and I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to a string, and then we get whack 1 a bunch of times, fine. Does anyone know what will happen if I subtract 1? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Wet bad.
All right. It was the 90s. So I shouldn't have overloaded plus. Obviously, Java can do it because it's a typed language. In JavaScript, I should have used something else like dot, like Perl used, only they had to change that. You have to realize PHP was born the same year, in, I think, June of 1995. I knew Rasmus Lerdorf through the Active State Advisory Board, and I ran into him a few months ago. And it was good to catch up. And Rasmus has worked on PHP, and PHP 7 has optional types and things like that. Things get better if you work on them long enough. But back then, these dynamic languages were considered silly languages. They were not for real programmers. And of course, Java needed such a language. It needed a little brother language. Because otherwise, you would just be looking at this all the time. Java didn't work out on the client, and there are reasons for this. But I'm going to go back further to the mid-90s, the last good TV season, according to Vox.com. This is where the picture comes from. And that's when I went to Netscape a year late. I should have gone the first year, but I didn't. I didn't have the chainsaw for the hand at that point. I would go to Stanford University and read papers because the venture capitalist John Doerr said all you had to do was hang around Margaret Jack's Hall to be a successful something. And so I did that, and it didn't really help me be a VC, but it helped me quickly implement something in 10 days that became JavaScript. One of the constraints that isn't obvious was there was going to be a server-side product, sort of like PHP, based on Mocha, JavaScript. And so I actually wrote a bytecode compiler and interpreter in those 10 days. And I was inspired by this paper by James Gosling, just a little paper from SIGPlan. And it talks about sort of how to generate efficient machine code from bytecode. It talks about Java's kind of wacky, mostly typed bytecode. It's not a bad paper, and it shows early Java, and there's that nice, or not so nice, Java bytecode on the right. It turns out that by being inspired by this paper and writing a bytecode interpreter, I put some things into JavaScript that I didn't have to. I put in the bitwise operators from not only C, C++, but also Java, including the unsigned right shift operator. I wrote a bytecode compiler and interpreter, therefore I had to write a way to decompile bytecode back to source. I didn't want to hang on to the source then. There wasn't much memory on 16-bit Windows machines. There were a lot of problems. I think people who remember the early version of JavaScript that came out in 1995, it's amazing it survived. It did not have nested functions, for instance. I didn't have time to do closures properly in those 10 days. And it had lots of hacky substitutes for a real standard library. It had the date constructor, which was based verbatim on Java util date, which had Y2K bugs. If you remember Office Space, they were all fixing Y2K bugs. I think it was Gosling. It had get year, which returned a 2-digit year offset from 1900. We fixed this when we standardized JavaScript, and Java eventually, I think, deprecated Java util date. But it's amazing how badly designed it was, considering it was in Java. It made JavaScript look like Java, which was the whole point. The other thing that I did in a big hurry, not all in those 10 days, I had sort of the rest of June and July really to do the rest of it, was the integration with the Netscape browser, which was as important as the language. The language could have all these, these silly gaffes and warts, but if it didn't actually do something in the browser that was interesting, it would have completely flopped. And it turns out Java couldn't do any of those things. Java just had a rectangle. Java was a plugin. It was an applet. But here's an example I found on the Internet Archive. Unfortunately, not all the art is there. This is from an early adopter named Bill Dortch. He did a really good job using JavaScript dynamically back in the days. If you click on these links, you get generated pages. These are all client-generated pages. This is like a single-page application using frames and frame sets, using JavaScript on the client side to compute presentations from downloaded data. And here's what the data looked like. It was a gallery with artists and their works. And it had to be written in very early JavaScript. There was no JSON. You had to write it using constructor calls, nested. Bill Dortch nicely indented them here. But you could do a lot with this. And it showed the promise, even then, of what became, in Microsoft's parlance, DHTML or Ajax 10 years later, or the modern world we all take for granted. It was there in the beginning. And there was some art, fortunately. And it worked, barely. So that I want to stress that the language design wasn't the only or even the most important factor. It was the integration with the browser. Since then, thanks to those bitwise operators, we've discovered things like asm.js, which is a statically typed subset of JavaScript that has definite performance. It has no garbage collection pauses. It has no just-in-time recompilation pauses or performance cliffs. And I'll get into what that's inspired recently that was announced just the other week. We have the 6th edition of the ECMAScript standard. And when I say ECMAScript, I'm referring to the standardized version of JavaScript because Sun wouldn't donate the trademark. They said, no, it starts with JAVA, so we are not going to give that to the standards body. And by the way, they had their lawyer suing everybody in the world who had a website starting JAVA. There was somebody who had a site named Javanko. It was his surname. And he got a cease and desist letter from Sun's lawyers saying you can't have your website named Javanko because it starts with JAVA. And he said, no, I'm going to stick with that. JavaScript probably should be donated now by Oracle. I don't know if it will be, but it's arguably not a defensible trademark anymore. Meanwhile, ECMAScript is an unwanted trade name. It sounds like a skin disease. We have other things in JavaScript now. We can get to the hardware. We can actually get into the GPU. This is thanks to work going back to when I was at Silicon Graphics with the original GL, then OpenGL, which standardized it, OpenGL ES for mobile, and then the version of OpenGL ES called WebGL that Vladimir Vukicevic did at Mozilla and took to the Kronos group, which is now in all the browsers. It's in iOS WebKit. It's enabled in WebViews. It's in IE 11 and up. A little shaky there, but it's looking good in IE 12, or Edge, excuse me. Typed objects, an evolution of the typed arrays from WebGL that allow you to treat memory as a packed array of integers of various sizes. Very important for ASM.js, very important for GPU programming, obviously. Typed objects are a generalization of this. We hope to get into a future version of ECMAScript, perhaps ES7/2016, I don't know. And then this sort of tool culture I'll also talk about, where TypeScript from Microsoft and then Flow from Facebook are getting very popular. TypeScript especially, people are running not just linters, but actual static type checkers on their code, and they are finding problems ahead of time. These really are warning systems. They don't generate any runtime checks unless you enable an option that can be quite expensive, so maybe they should have called it warn script, but TypeScript's a better name. So if you go back to that Gosling paper, there was a class vector. You can now write something like that in ES6. It's still dynamically typed, but here I've taken some pain to hand annotate the uses of variables and values to show how ASM.js actually inserts casts to produce a statically typed subset of JavaScript. You can see the vertical bar 0 in 3 or 4 places there to cast to a 32-bit integer. Those bitwise operators are how you get 32-bit integers in a world of only IEEE double precision floating point, which is what JavaScript's number type is. Because I was in such a hurry and I knew I could project integers into doubles, I stopped at double. But I knew, something told me as an old C hacker, I wanted those bitwise operators. And they would be useful even in 1995, even for a sort of a toy kid brother language. So I put them in and it's paid off. And here's, again, from Gosling's paper, there's Java bytecode on the left, and there is a sort of hand approximation of ASM.js on the right. And it's interesting to point out a couple of things about this. It didn't really pay for Java to reduce to a postfix bytecode. You had to have the verifier. It had to check that types were consistent in the control flow graph at join points. Until they added stack maps, it was expensive. I remember my pal Michael Franz at UC Irvine wrote a paper about how you could torture the Java verifier 10 years ago by giving it artificial spaghetti code that would cause fourth power complexity and denial of service attacks on the Java verifier. Meanwhile, JavaScript has only structured control flow. Every control flow graph is reducible. You can check types linearly in linear time as you parse. It turns out to be a win, except for the cost of parsing all that keyword-rich verbose source, which I'll get to. So JavaScript is everywhere on the web. Java is only on the server side. The plugin, you can still get it. Occasionally, you need it. There are banks in Scandinavia that require it for smart cards. Kind of a boondoggle. It was unfortunately not a well-maintained plugin, the Java plugin, and it was being used for security exploits for malware. It was the #1 bought and paid for vector for malware. I think Oracle's fixed that up a bit, but it's kind of too late. Java failed on the client. JavaScript succeeded, and I think that's because it was good enough that it could be evolved. And it had this ASM.js statically typed subset inside it. And that is actually being used now, not just by people writing hand code, but also by compilers. Compiling JavaScript is old news. Many of you know about this. If you haven't been aware of this, I'll just run through a few of the tools. Google Web Toolkit, and I should mention OpenLaslo before it. CoffeeScript helped quite a bit. People could see, like Gary Bernhardt, who is a Rubyist, I think, could see that there was a better way to use JavaScript without having to pay for the heavy C-like syntax, and you could use ahead-of-time compilers to generate JavaScript that was still pretty debuggable, still pretty close to the level of the source language, sort of trans-compilation, transpiling, it's a pretty ugly word. And then Dart, which is now, I think, committed to being a really good compiled to JavaScript language, also has a virtual machine, but that virtual machine is not getting into browsers, not even to Chrome. That was news this year. Let me do a quick demo if you haven't seen this. This is something by Sean LeBron. It's written in ClojureScript, which is David Nolan at Swanaded on Twitter's version of Clojure, Richicky's language that compiles to JavaScript. So it's another compiled to JavaScript language. And Sean did this nice solar system of JavaScript where JavaScript has grown like a sun, a nice yellow sun, not too big. It has these standards inside it that happened over the years. ES3, the third edition, was the 1999 era version of the standard. When I was at Netscape, we took JavaScript to the ECMA, at that point, European Computer Manufacturers Association standards body. And we did it because they had already gotten Microsoft mad at them by trying to standardize the Windows API, because the European governments wanted a de jure standard for all this important software that used Windows APIs. Microsoft tried to sue them and failed. ECMA seemed like a good place. Netscape was under pressure. Bill Gates was complaining. Netscape keeps changing JavaScript every release. Like, he's never done that with Visual Basic. But he had a point, and Netscape was not careful about standardizing things. There was wild innovation. They were adding frames and frame sets, plugins, new image types. Image came in with Mosaic, but there was crazy innovation without standardization. And because Microsoft was competing effectively with Internet Explorer by 1996, let's say, we at Netscape felt pressure, moral pressure. We took JavaScript to ECMA. We did standardize it. It was a really good effort. I think it forged some bonds that are still going today. Microsoft contributed because they wanted to gain market share from Netscape. and they wanted to have a standards-approved implementation of JScript, their version of JavaScript. But they actually had somebody really good, Sean Katzenberger, who did a lot of the heavy lifting in the spec. Simon contributed Guy Steele. It was great to have Guy. Guy brought Dick Gabriel along for fun to a couple of the meetings. I think Richard Gabriel wrote the clause 3 of the ECMA spec, which is a very nice chapter sort of introducing JavaScript concepts. ES3 then rolled up the follow-on innovation that I couldn't do in 10 days, including nested functions and closures, regular expressions, switch statements, a lot of things that we take for granted. This became the bedrock for the Ajax era of 2005. And Firefox, I also did Mozilla and Firefox, so I had to restart the browser market in minor detail to get ECMA back in business, but that led to ES5. There was also a 4th edition, which we mothballed. It failed. It produced useful negative results. In some ways, it was prefiguring what we see now in TypeScript and Flow, or things that are going into ES6 and 7. It was too much. It was an attempt to take sort of a forked version of JavaScript that was in the Flash player from Macromedia and then Adobe, and unify that with the 3rd edition of ECMAScript. It was based on work by Waldemar Horwath at Netscape. I gave Waldemar the keys to the kingdom in 1998 when I went to found Mozilla.org, and I said, go, fix JavaScript. And Waldemar said, I love, Cardelli object-oriented, type systems. I'm going to go sort of graft that onto JavaScript. And this was before, I think, any of the work on gradual typing or hybrid typing. Robbie Findler and Phil Wadler and Cormac Flanagan, those people hadn't written their papers. So Waldemar came up with a bunch of interesting ideas, but they couldn't be done on the web. Macromedia, which then got bought by Adobe, took them to heart and put them in the Flash player because they could make their programmers run static type checkers. They'd make them run tools that would compile packages that would have definite types, definite name bindings. And that became one of the inputs to the 4th edition, and it was just too much to try to standardize, and it still doesn't really work on the web. We never could figure out how to make some of it work. So we skipped ES4. Now, ES5 was the big 2009 standard. At this point, we were just rolling up a lot of things that we'd done as browser implementers that I'd done in Firefox and SpiderMonkey, things like array, map, reduce, for each, reduce write. These were de facto standards, and this is another point I would make about innovation on the web. You have to have implementations and developers, in fact, lead users, writing libraries, anticipating the standards, informing the standards, actually creating new standards. They have to be able to run ahead of the standards committees, which are a terrible place to do any kind of design. And you do get a bit of a hodgepodge effect. It's inevitable, but if you have good stewardship in the standards bodies, then you can harvest the best ideas from the developers, from the browser implementers. And ES5 did that. Now, ES6 is in some ways ES4 plus 6. It has a lot of new things in it, and I'll talk about that in a hurry soon. And then ES7, things are still going. Sean LeBron was optimistic that we'll have ES8, which is supposed to be in 2017. With macros, we'll see. But one of the points this talk makes, which is nice, is that people are used to using tools now, the so-called transpiler or compiler, a linter at least, if you're writing hand JavaScript, a module system, since up until ES6, JavaScript lacked that, and it still isn't fully implemented in any browser. This is a new kind of code culture for JavaScript. In the old days, a lot of people writing JavaScript would say, I want to write raw JavaScript. I don't want to use any tools. I want to shift reload after I edit my file. But now people use Node.js-based automation that watches files, and it's all magic, and it works. The tools run all the time when they need to. And so this code culture has enabled compiled to JavaScript, static type checking for JavaScript, which has been informed by all that great research on gradual types. Anders Helsberg has led the team at Microsoft that did TypeScript, which was very smart, and it's still growing. And they've committed to sort of reconverging it with the evolving ECMAScript standard, which is smart. They didn't make a different language that had to go its own way. Flow picks up on the sort of syntax that we've now reserved for the future standard, so-called colon annotations, var x:/t. And Flow, as I can tell you, has more sophisticated analyses, more sophisticated inference, so that you don't have to write so many annotations as you do with TypeScript. There's the august Clojure compiler, not Clojure, but Clojure from Google, which also is doing sophisticated analysis these days. Requires some annotation, sometimes done in comments. But these are all sort of circling the same sun. They're all in the solar system of JavaScript, figuring out how to add some kind of typing. And there's an experiment in V8 called SoundScript, which I hope succeeds. This is being done under the aegis of the ECMA committee, TC39, which is going to take ideas that were in ES4 and simplify them and try to improve the language in an opt-in way so that you can have less of the JS WAT effect that Gary Bernhardt amusingly mocked, and you can have optional types. And these types will mean something at runtime. These are not just warnings. CoffeeScript, have to give it credit. Dart is now in orbit, captured it nicely. It was kind of a rogue planet at first. Clojure script, David Nolan's language based on Clojure, which this presentation is written in. And the list goes on. You know, it's a very large solar system. There are hundreds of compiled JavaScript languages. So to get back to this, one important compiler I'll mention is Emscripten by Alon Zakai of Mozilla Research. Based on LLVM, it's a C and C++ compiled to JavaScript solution. It's a backend for LLVM that generates JavaScript from LLVM IR. It has to reconstruct loops from the LLVM control flow graph. It has to prove certain facts about the code it was generating to make it really fast. This led to ASM.js, and as I say, ASM.js was in some ways discovered by Alon and Dave Herman and Luke Wagner at Mozilla Research, and formalized. And Dave wrote the type system for it. You can see it at asmjs.org. So JavaScript virtual machines are now running very close to the metal if you use this type subset. You don't have to declare all the types, so you have to use those bitwise or zero casts. And it's painful to do it by hand, but the compiler can do it. And gzip compresses it nicely, though it does turn into a parsing overhead. Of course, in the meantime, Java has persisted on the server side. It's done well, and you have things like the sort of dynamic language support in the JVM now, which is doing very well. So I like to say the circle is now complete. I'm afraid this makes me Darth Vader, though that's not really good. James Gosling over there. I don't know if anybody saw this. Mark Hamill is now the same age Alec Guinness was when Alec Guinness was in Star Wars, the first movie, and now Mark Hamill's in this new J.J. Abrams movie, which I'm sure is going to be a travesty. Anyway, WebAssembly. So what is it? ASM.js, the definite performance, no GC pause, statically typed subset of JavaScript, has led to a great sort of peace treaty among Google, Microsoft, Mozilla, and even Apple. Phil Pitzlow's here somewhere, I think, to work in earnest on a second syntax for JavaScript. When I was doing JavaScript, scheme in the browser, I think Tom Lord was starting Guile. Maciej Stachowiak worked on Guile a little bit. He ended up going to work on WebKit at Apple. And people know about Scheme. They know how to do fast languages. Why are we stuck with this JavaScript syntax? It's so verbose. It's costly to parse, especially on mobile. Let's make a second syntax. Well, now you have two problems, except that if the primary syntax, JavaScript, is just too expensive, even if you gzip it for transfer compression, you have to ungzip it to parse it. Uses a lot of memory and time. Time for a second syntax. But we now know how to do a better intermediate form than a postfix bytecode like Java has, for instance. So let me just refer you here to the GitHub, where the big browser companies are all working on this design based on ASM.js. It starts out as co-expressive with ASM.js, and it grows from there. Some of the design was informed by things like Ben Lifshitz work on JS Zap, and there was previous work from Michael Franz and Christian Stork on arithmetic coding of abstract syntax trees. So instead of using a bytecode for some kind of a stack machine, the plan is to use efficiently binary encoded abstract syntax tree. There's some debate right now how much pre-order, how much post-order, because you might want to interpret this. You might not want to always compile this. There's a fair amount of cold code that's loaded on the web or in any large application, and sometimes that code warms up only once. It runs only once, so it doesn't make sense to compile it. So I think the lead thinking is you might have sort of a post-order encoding for expressions and pre-order for control flow structures, which are currently equivalent to statements. Now, we also want to get rid of the statement expression dichotomy in this new syntax. JavaScript, unfortunately, has statements from C, from Java, but WebAssembly, WASM for short, need not. So the nice thing about this is that it starts out as the second syntax for ASM.js. It can actually be implemented in browsers by a little translation library, a so-called polyfill, that translates the binary syntax to ASM.js. And that can run quickly. In fact, it can run faster than if you had just taken the entire large program as ASM.js. So Emscripten is supporting this prototype. This is all experimental, collaborative design in the open in a W3C community group. Anyone can join that community group, so I encourage you to do so. There are lots of people already contributing. To give you a feeling for what it looks like, there are storage types like indate, int16, and there are 32-bit and 64-bit integers and floats. There are ways of viewing memory, which you recognize from typed arrays. There are operations which then impute signedness or unsignedness appropriately. And because the Google Portable Native Client team is contributing, this is really great news. We have all the excellent work and research they've done over the years to try to wring undefined behavior out of the C and C++, not just language, but sort of tool, memory model, hardware. The entire stack has to be more definitely specified than it is for a C compiler. Because we're making this available on the web, we're worried about security, and we want to have less non-determinism. We want software fault isolations, just like you have in ASM.js, just like you have in Portable Native Client. If something goes wrong, the program crashes, but you cannot pwn the machine. You cannot take over control flow and do return-oriented programming or anything like that. So anyway, this is all on GitHub, and I encourage you to look at it. There's a roadmap, again, informed by the ASM.js and Pinnacle people's future thoughts that includes support for dynamic languages, support for tooling, things like dynamic linking, garbage collection, even just-in-time compilation of WASM. This is big news, and it's not all going to happen at once. It's going to be done in the open. I hope to see a sort of experimental nightly build support in Chrome and Firefox, and in the preview release of Edge for some of this over the next, I'd say, 6 months. But that may be optimistic. I don't think it should wait, though. I think the big lesson I learned, do something in 10 days when you have a chance to get market share, and it will succeed. And that is important for WASM. I think it's great that ASM.js is being optimized by Microsoft Edge, i.e. 12. It's great that Chrome V8 is also doing well at it. The new turbofan backend is optimizing for ASM.js as sort of part of the job of optimizing for all JavaScript. But now with WebAssembly, we have a chance to really improve the sort of parse time. And once we have all the browsers supporting this second syntax, we can let it diverge and let its semantics grow beyond what we want to push into JavaScript. I used to give talks where I'd show the yin and the yang symbols, JavaScript serving two masters. It was supposed to be a happy compromise. Never really is. It doesn't end well. With WASM, we can relieve JavaScript from having to be both a great compiler target language and the successful dynamic hand-coded language it is. JavaScript can grow less, and WASM can grow more. So let me do some demos, because I don't want to take too much more of your time, but I do want to leave a little bit of time for questions at the end. Just to show you where this all started, before I think ASM.js was formalized, Fabrice Bellard, the super hacker who did QEMU, TCC, and many other things, did something that was pretty amazing. He did a PC emulator in JavaScript. He used typed arrays. He used sort of his own hand-coded ASM.js, and I hope it boots. It is starting. Please start. That's how my, okay, this is a session history bug. I'm going to have to start it over. Yeah, there it is. Good, thank you. This is the Firefox nightly build. I'm not sure what that big pause was. It's actually Linux running on an emulated PC. Oops, now I went forward. It's still there. Got to get the keyboard focused in the right place. You can run TCC. This is all running JavaScript. You're in the matrix. You've taken the blue pill. You're happy. And at some point, it'll come back. It must be. This was faster in my hotel room. All right, we're timing out. Wow. So you can see he's got a full PC emulation here, hardware emulation, and we're getting like IRQ timeouts. All right, let me get back to this. Something didn't work there, but I'm going to play games instead. This is an example of ASM.js. This is compiled with Emscripten. It's the Unity 5 engine. It's a zombie game, so you have to forgive the gore, but I won't have to kill any zombies because my sentry chickens will do it for me. Unfortunately, their machine guns tend to overheat and they explode. It's very sad. But this is not only showing off ASM.js, but also WebGL, of course, web audio, full screen APIs, a lot of things we added to the web over the last few years to make it more of a complete platform for things like games. I better take some health. Anyway, full frame rate, supported target for Unity. Also, Epic Games Unreal Engine supports the web now. This is, I think, primarily due to the work we did at Mozilla, and it was picked up on by Microsoft and, of course, other browser vendors. And it works for lots of games. There are many games based on Unity, many based on Unreal Engine that are all licensed, based on SDKs or game engine source licenses, and they all work now on the web. You just press a button, you run it through Emscripten, you get code you can download. Again, it's JavaScript, so it's a little big. Can't wait for WASM, which will be more concise, faster loading, faster starting. But it's all very nice. And yes, some graybeards telling me what to do, story of my life. But at least if I can get this Fabrice Ballard thing to work. This JS Linux. This was really important to us before we formalized ASM. It just was amazingly fast, and it's a full PC emulator running Linux, running TCC. Maybe the network's going to let me down here, but while I'm loading that, you can also see something called suitejs.org. That's what you're seeing right there. That's macros for JavaScript. So there is hope. Maybe it won't be in ES 8/2017, but there is hope that we will get hygienic macros, and you won't have to keep coming to the standards body saying, please add more special forms for convenience or to express new semantics. Instead, you can, we hope, use macros and have a smaller language kernel semantics. Or you can use WASM macros, presumably. WASM, again, WebAssembly is not meant to be hand-coded, though Nick Bray of Google is working on an assembler for fun, where we think people might write a little WASM by hand. Mostly it's a compiler target. And it really won't be that fun to write by hand. I think the Hotel Wireless is letting me down. But if this eventually loads, you'll see, boot up. I can even write a program. Here we go. Let's see. I'm back. So if I compiled, I didn't compile. Let's see. Hello. Let's try this. Is it going to work? And it's not. Yep. All right. Not sure what's going on there. It's timing out, so the program is not working. You can play with it. It's on the web. You can actually use Linux running on JavaScript. And that was so fast, we realized there was something there. Emscripten was coming up. We realized through Alonzo Kai's work, you could cross-compile crazy big C programs, C, Python, Lua, Ruby, you name it. Led to ASM.js, led to WebAssembly. So when I do these talks, I usually end up with some great 90s homage involving a Wesley Snipes movie no one remembers. It's actually Passenger 57, but people think it's Blade. I don't know why. That makes even less sense. And I had to explain it on Hacker News because nobody appreciates old movies anymore. Always bet on JS, like Wesley's slogan where he told off a bad guy saying always bet on black. Doesn't really make sense, except with Wesley, he's going to kick the bad guy's butt. With JavaScript, it happened to be at the right place at the right time and happened to grow. It took a lot of work, frankly, to evolve it. And now we have WebAssembly. So I've updated my slogan to always bet on JavaScript and WebAssembly. Thank you very much.
Thank you for a very interesting talk. I was actually most blown away at the beginning of it when you said, well, they hired me to do Scheme. And I was in a haze imagining the world as it would be if they had carried through on that. They had reasons why they wanted it to look like Java. OK. So the question is, did you consider doing a scheme with a syntax that looked like Java, which sounds completely bizarre, but of course, if you know the history,
yes.
You know McCarthy's original intention for Lisp was a different language, was a different surface language.
Sure.
And S expressions were just a hack,
right.
which happened to stick.
Just like JavaScript. Yeah, no, there wasn't time. I had to do a demo. The Netscape code base had to work on 16-bit Windows, Windows 3.1. There wasn't a scheme engine I could have used. I didn't have time to create a front end that could sort of translate C syntax, lower it to S expressions. I didn't even have a proper garbage collector. I had to hack reference counting in. There were a lot of memory safety bugs. Netscape was an incredible rocket. I'm not saying a good thing here. Everything was being rushed. There was a sense of doom, not just from the sort of go public ethos, which was embraced by the founders, especially Jim Clark, but also Microsoft was coming up in the rearview mirror. And Mike Homer of Netscape, the marketing executive, no longer with us, unfortunately, said, we were the little Yugo, and there was this monster truck of Microsoft on its license plate coming up in our rearview mirror. It was getting awfully large. And it drove Netscape right off the road, right? There was a famous US v. Microsoft antitrust case. Mozilla.org was the remnant, sort of escape pod. We didn't have time. If I had more time, I would have done Scheme. And I would have even fought back against this, make it look like Java, or used sort of the Lisp to C syntax thinking that was around. But there was no time. There was absolutely no time to do it right. I met Richard Gabriel through the standards process, and he's famous for this worse is better essay, which I think a lot of people misunderstand or misappropriate. Sometimes worse is just worse. JavaScript got by through the skin of its teeth. Let's just leave it at that. But I'm glad that it got by enough that we have things like WebAssembly, we have this incredible reach of the web and all these programming languages now compiling to it. Sure, it could have been better if there was more time. There just wasn't more time. Thanks.
I guess my question about WebAssembly is why now? This is an idea that I feel like people have proposed much earlier, and it seems like a really good idea, but why is now the time to do it?
Yeah, it's a good question. We've talked about this. I mean, I mentioned JS Zap from Ben Lifshitz. I think Michael Franz, the Christian Stork's work was even older. We've thought about second syntax for JavaScript, but even beyond that, we've thought about a bytecode for the web. Everybody on, sort of the sophomore question on Hacker News, why can't I have a bytecode? But Java bytecode actually was a problem. It was not well designed. It was frozen for binary compatibility reasons, which then impaired the language evolution, in my opinion, things like erased generics. So once you have two problems, two syntaxes, you can get into this sort of trouble where you freeze one or you feel compatibility constraints prevent you from changing one, and that limits what you can do in the other or in the underlying semantics. And that was a problem we didn't want to rush into with JavaScript. I remember many years ago on the ES Discuss list, Maciej Stachowiak of Apple said, look, we can do a syntax for JavaScript that's a bytecode, but now we'll have to freeze it, and we'll have to version it, or we'll have to figure out how to compatibly extend it, and we'll probably get it wrong. So there was great resistance to doing that. Meanwhile, it was easy for Microsoft to do .NET, the CLR, for Google to do things like native client or the Dart VM. Big companies with lots of resources can do the obvious thing, but they can't get it into the browser. And one point I'll make about WebAssembly that's important, there's only one VM. It's the JavaScript VM growing a second syntax and then evolving its semantics to express more than JavaScript can or should express to support native code, to support other programming languages, maybe call CC someday. That one VM principle is extremely important. Trying to put two VMs into all the browsers has been attempted and failed. I paid Mark Hammond to put CPython into Mozilla just for ActiveState and a few other companies. We took it out. It was too complex. Dart VM was supposed to go into Chrome. Failed. It does not go in. Will never go in. The idea behind WebAssembly that's critical here is to have one virtual machine evolve. Once that breakthrough was reached, once ASM.js proved the performance could be asymptotically close to portable native client, I think everybody got together among the browser vendors. You could say it's politics, you could say it's learning process among multiple companies. There's lots of ways to analyze it, but I'm just glad it's happening now. Better late than never.
Hi. So regarding ASM.js and WebAssembly, people, and you also said it's a typed subset of JavaScript, but I don't think this is true. In general, this is much more restrictive than typed subset of JavaScript. In other words, it's also much less than a typed subset of JavaScript. It doesn't have any kind of GC. It only has ints and raw memory. It doesn't have any kind of reasonable interaction with interrupt with the DOM or anything. Even in the medium long term of WebAssembly, I have seen that there is hope to be able to manipulate objects coming from the GC, but it's still not a GC language or a GC bytecode. Is there any hope that somehow, at some point in the future, we can get something like a garbage collected typed bytecode or?
Sure. Again, I invite you to look at the GitHub. WebAssembly is a moving target. So is JavaScript. It was a big mistake, in my opinion, for the Dart people to say JavaScript can't be fixed and can't change, because it has, and it is being fixed. Same with WebAssembly. It is starting as co-expressive with ASM.js, which is typed, but doesn't have garbage collection. Your notion of typed must include more expressiveness than is there for the C and C++ compilers, and that's fair. We will get there. It'll take a couple of years, I think maybe 3 or 4 years even, but on the roadmap here for WebAssembly, you see garbage collection and DOM integration, you see just-in-time compilation, memory bigger than 4 gig, which is quite necessary, coroutines. There's a large roadmap here, and it's well understood, especially thanks to the work of portable native client folks, the ASM.js people at Mozilla. This is all in reach. When I was at Mozilla, we were working on SpiderMonkey. We thought about how to expose garbage collection to guest language. We had that Python integration 10 years ago. We had a cycle collector based on Bacon and Rajan 2001. So we've been around this block. It wasn't practical to do it with 2 VMs. Now we have 1 VM. I think it's within reach, but it will take time. You're right. Just don't assume that everything's in stasis. The web is evolving rapidly, JavaScript's evolving, WebAssembly is evolving.
Hi, I'm Ben. I actually work on the WebAssembly side in Chrome and V8 and Turbofan. I think this really happened because of it was communication between engineers and not necessarily management. We kind of all got together and together and decided that we needed to design something to solve this problem, and ASM.js was a step along that way. And actually, we did optimize for it, but we kind of realized it was not the right solution. And so this is kind of a way to actually design something for a particular purpose. And it was really contact between people at the bottom level who basically got together and decided, what if we could do this? Wouldn't that be the right solution? So, I mean, that's an ongoing process. Goes back more than a year probably, but now it's all open, and actually we're really excited about this. So,
thanks, man. It really is engineer. We have a problem with ASM. Parsing JavaScript costs too much. We have another problem with JavaScript as a language that we want to be good stewards of. We don't want to keep extending it to be a compiler target and add crazy things that are hazardous to hand coders. We're just engineers solving problems, and that cut through a lot of the politics, I think. The time was right. I remember 2 years ago I visited Microsoft, and I talked to Steve Luco and Anders Hellsberg sort of on background about ASM.js, and they got excited. So it's been a gradual process, and I think it will continue.